So the next topic we're going to be talking about is effective annual yield, or the effective rate, which is the simple interest rate that produces the same amount of money in an account at the end of the year as one when the account is subject to compound interest at the stated rate. What this is useful for is often comparing two different rates with different compoundings. You're not sure which one's better. Well, if you look at the effective annual yield, then you can compare them because it would be the same for both as if they were simple interest. Suppose that an investment has a nominal interest rate R in decimal form and pays compound interest N times per year. The investment's effective annual yield, Y, in decimal form is given by the formula y equals parentheses 1 plus r over n raised to the n minus 1. The decimal form of y given by the formula should then be converted to a percent. So if you're selecting the best investment from 2 or 3 investments, the best choice is the account with the greatest effective annual yield. When borrowing money, the effective rate or effective annual yield is usually called the annual percentage rate. So here's an example. You deposit $4,000 in an account for 1 year. Calculate the future value if you compounded monthly at 8%. Now this is just regular formula. So our compound formula, I'm just going to write it here at the top, from before is A equals P parentheses 1 plus R over N to the NT. Whereas the simple interest is A equals P parentheses 1 plus RT. So for the first problem, we have A, P, R, N, T, where our P is 4,000. It's for 1 year, so that's T is 1. Compounded monthly, so that's 12 times a year, and the rate is 0.08. So when I plug this in, 4,000 times parentheses 1 plus 0.08 over 12 raised to the 12 times 1. So I'm going to type that in, times parentheses 1 plus 0.08 divided by 12 parentheses raised to the 12. And I'm just going to hit enter. I know 12 times 1 is just 12. So that gets me 4,331.998. Now that 8 makes that 9 go up, which makes that 9 go up, which makes that 1 go up. So that's going to be 4,332. Okay? So at the end of the year, I'll get $4,332. Now let's do simple interest at 8.3. So we have A equals P equals R and T. We don't have an N because it's simple interest and we only calculate the interest once. So we have still 1 year. The rate is actually this time 8.3 and we still have $4,000. So we have A equals 4,000 times 1 plus 0.083 times 1. So now I'm going to type that in the calculator. We have 4,000 times 1 plus 0.083 times 1. And that gets us 4,332. Very interesting, isn't that? So we didn't use the annual effective yield rate. I'm just trying to explain what annual effective yield is when we did compounded monthly and simple interest. Therefore, the future value at 8% compounded monthly is the same as the simple interest, just compounded that once at 8.3%. We call the 8% the nominal rate, and we call the 8.3% the effective rate. So if you're plugging it in the formula, you have to use the 8%. If you want to be able to compare compounded monthly at 8% to compounded quarterly at 9%, which one's better, you could calculate the annual yield and you could find that out. So we're actually going to use the annual yield now in the next example to find the effective rate. So we're going to use the R equals the nominal rate of the 8% for the first example, compounded monthly. So if I'm going to try to find the nominal rate, I have y equals parentheses 1 plus my rate, which from above was 0.08, and my n was compounded monthly, which is 12. So we have 0.08 divided by 12 raised to the 12 minus 1. So when I work that out, I get parentheses 1 plus 0.08 divided by 12 parentheses raised to the 12th, then minus 1. I had to hit over, but most of your calculators probably won't be up high, and so you could just hit minus 1 after that. So my y is equal to 0.082999. So this 9 tells that 2 to become a 3, which gets you 8.3%. So if we were going to use simple interest, we could use 8.3%, which is the same as the 8% at compounded monthly. So, which is what we kind of just proved up here. We said if we did it at 8% compounded monthly, we would get the same exact price as if we just did simple interest at 8.3. This formula, y equals parentheses 1 plus r over n to the n minus 1, will get you that annual yield rate. Okay? Let's try this on an example of its own. So what is the effective annual yield on an account paying 5%, so the R is 5% or 0.05, compounded quarterly. Quarterly, that's 4 times a year. So when I plug that value in, I have 1 plus 0.05 over 4 raised to the 4 minus 1. So I use my calculator, parentheses 1 plus 0.05 divided by 4 raised to the 4, then minus 1. This gets me 0.0509. So the 9 takes that up 1, so that's 5.1% is going to be my effective annual yield. I'm just being a little lazy and I don't want to write all that out. So even though the situation calls for 5% compounded quarterly, 5.1 is going to be the effective annual yearly rate if you were just going to use simple interest. So the real reason why this is helpful is if you're comparing two investments. So let's say we are trying to find the annual yield for each of these investments and then select the better investment. If you need to, round to the nearest tenth of a percent. So investment A, now this doesn't, I don't even need to know how much money you're investing. I don't need to know how much you want at the end. I don't need to know the A or the P at all. All I really need is the R and the N. I don't need to know how long you're going to be investing as well. So the R is just 5% compounded monthly. The other investment, we have the rate being 0.0525, and then this is going to be compounded quarterly. So investment A has a smaller interest, but you're compounding more often. Investment B has a little bit higher interest, but you're not compounding quite as much. So we're trying to figure out which one's better. So for the investment A, I'm going to plug in my values, 1 plus 0.05 over 12 to the 12 minus 1. Take out my calculator, 1 plus 0.05 divided by 12 raised to the 12, then minus 1. That gets me 5.1% for the effective annual yield. All right, for the investment B, I'm going to do the same. So we have y equals 1 plus 0.0525 over 4 raised to the 4 minus 1. So we're going to try this in our calculator. parentheses 1 plus 0.0525 divided by 4, close the parentheses, raised to the 4 minus 1, and that turns out to be 0.0535, so that is going to round it up, so I have 5.4%. And so which investment should you choose? You have 5.1 for investment A, which is the effective annual yield, and 5.4 for the effective annual yield for investment B. So we will choose investment B because it has a higher effective annual yield. 5.4 is much better than 5.1. Whereas if you're just looking at 5% compounded monthly versus 5.25 compounded quarterly, it's a little hard to know which one's better. One's higher interest rate, but one's compounded more often. It's hard to tell. So what we do is we convert it into the effective annual yield, and then it's really easy to see that 5.4 is way better than 5.1 if this was just a simple interest problem. And that concludes our lesson on compound interest.